Hello viewers, welcome back to my channel. In this session I shall be discussing on inverted page table. This is one of the second type in the types of the page tables. So what exactly you mean by inverted page table? This is the diagram that is given in the textbook. So normally before I explain with respect to the diagram, I would like to tell you what exactly is the idea behind this. Now let us take, see always till now I have been telling you about one particular process P1 having different pages. For example, page 1, page 2, page 3. Let us assume P1 is a process which is having 4 pages. But in multi-programming environment, more than one process will be executing at the same time. So in the main memory, you will be having pages of process P1, then you will be having pages of process P2 if P2 is having 5 pages, and you will be having another process, let us take P3, which is having what 3 pages, PG1, PG2 and PG3. Like that, all the pages, that means pages of different processes will also be stored in the main memory. And for each of this particular process you need a page table. Then how many page tables you require? Just imagine if the in the multi-programming environment, if there are 50 processes that are there, for each of these process you have some 100 pages, then that many page tables. That means for 50 processes, each process is having 100 pages. That means for every process there will be 100 entries. So you are going to store what all those page tables, the page tables of all those 50 processes in the main memory. But at a time the CPU is not executing all the pages of all the processes. It is only on timely basis that the different algorithms that are used scheduling. A particular page of one process will get executed, then once again context switch may happen, the other process page will get loaded, and that means only we are having at a time not all pages to be accessed by the CPU, only few pages from that complete huge list of pages. So what is the idea here? Instead of storing the information, that means in the page table in the main memory, you don't store the complete page information, okay, of all the processes. Rather, only those pages that are available in the main memory you need to store. I'll tell you in very simpler words like this with an example. Suppose if there is a process P1, okay, P1 page table will be what? P1 page table will be having, suppose P1 page table is having 4 pages, page 2, page 3 and page 4. These are the 4 pages. It is stored in some frame numbers F2. Page 2 is not present in the main memory, we'll put a dash. Page 3 is present in frame number 5. Page 4 is not present in the main memory, it is a dash. So this is the P1 page table. Okay. Like this, you are having another page, process P2, process page table. That means the number of page tables for process P2, let us assume it is having only 3 pages. So there will be 3 entries only, page 1, page 2 and page 3. So out of these 3, we can assume that page 1 is stored in F7, something like this. Page 2 is stored in F5, page 3 is not stored. Fine. Then you are having one more process. So let me take some 2 to 3, then only you will get the clear picture. We have another process P3. P3 is having 4 pages, then it should have 4 entries. So it will have PG1, PG2, PG3 and PG, 4 entries. PG, why? Because P3 is having only 4 pages. So the page table for P3 will have only 4 pages. And where are these pages stored? Let us assume PG1, there is no page PG1 that is loaded into the main memory. So it will be a dash here. PG2 is there. PG2 is present in frame number, let me take F1. PG3 is present in frame number, let me take some number randomly, F4. PG4 is not loaded. So these are the 3 different processes, these are the 3 different page tables of 3 processes, P1, P2 and P3. Out of totally how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Totally from all these 3 processes you have how many pages? 11 pages are there. Okay. But if you look, the number of pages that are present in the main memory are how many out of total 11? 1, 2, 3, 4, 5, 6. 6 pages are there in the main memory. But what exactly you are doing is, in a page table, you are placing what? All the page entries also. Even though it is nil, you have to keep one entry here. So that is also leading what? already you are reserving the space in the main memory. In this way, if you imagine the number of entries are too many for each page table, then you are using the memory space that is in the main memory, the memory very inefficiently. To make use of the efficient use of the memory, you have to go for the global page table. Global page table will always have what the page information of all the processes which are there in the main, that means which the CPU is executing, page information about only those pages that are there in the main memory. So that means it is going to store information only about 6 pages. I tell you now, in the global page table, you are going to store what? Only 6 entries, for which, for those pages that are actually present in the main memory. We say real pages. So make entries only for the real pages. So your global page table will have only 6 entries, no? Because you have to start like this now, process P1, PG1 and PG3. Fine. For process P2, it is PG1 and PG2. And for process P3, it is PG2 and PG3. 6 entries are there. But look here, what difficulty are you seeing now? At present, you can see there is one PG1, once again another PG1 appearing. There are two PG2s. So, in order to fetch the frame number for these pages, exactly we don't know this PG1 belongs to which process. This PG1 belongs to which process, because there are two pages, PG1 and PG1. That means same page number is there. We should know to which process it belongs to. Similarly, here also you can see there is one page number PG2. Another page number is also with PG2. We don't know to which process it belongs to. Whether this PG2 belongs to process P2 or P3, or this PG2 belongs to process P2 or P3. So that's the reason, apart from the page number, you have to store the PID, that is the unique ID given to the process, or you can tell it as process number only. So I can write down here process 1, so PG1 and PG3, okay, these are what? Belonging to process what? P1, PG1 and PG2, these are belonging to process P2, this PG2 and PG3 are belonging to process P3. Now if you look, what is that I have done? Now this has become now 2-piece information. If it is 2-piece information, PG1 and PG2 will be like this, okay. So once it becomes a 2-piece information, always the search is made for what? The search is made for the process number, and then the corresponding page number will be there here. And once you search in a combination, that means you are searching in a combination to get the frame numbers that are available in this. So you can see here for PG1 it is F2, F5, F7, F5 and F1 and F4. So, but what you have to do is, in the inverted page table, now this becomes your indexing. That's why I'll remove this as the content of the table. It is an indexing here. So, if this is the indexing, these are the contents of the page table. These two columns are the contents of the page table, whereas this is the indexing. So this is how what the inverted page table appears to be like this. The contents of the page table are the page numbers, and the indexing is what? Frame numbers. But if you look into the previous method, wherein the indexing was the page number and the contents were what? The frame numbers. So once things got reversed, so we say it is an inverted. So that's the reason the name for this page table is called as inverted page table. Always you are going to make a search with respect to these two entries only. CPU generates logical address. Now this time it is not just the page number along with the process PID. That's why in the page table we are storing, as I said here, no, these things. This is what? PID and PG. PID and PG for every process will be stored. Then once you search that particular entry, whatever, for suppose if for process P3 it is entering, process P3 is here. If it is generating a logical address for page P2, then this entry is searched. Okay, this entry P3 PG2. P3 PG2 is here. It is present in frame 1. So this indexing, whatever you get here is what? F1. And D, or I can tell you in this manner, the D is pointing to the displacement, and F will always give you what? The frame address, that is, now this is the indexing, no? So whatever is the index number here, that becomes your frame number or the base address of the page, and that base address will get added with the displacement. Displacement is here, okay? That is the location in the page that will get added up, and it will reach to that particular physical address in the main memory. So this is all about the inverted paging technique. Hope this session is useful to you all. Please like, share and subscribe to my channel. Thank you. Bye bye. Take care.